Hi everyone, and welcome back to the series where we solve data problems in both SQL and Pandas. This series includes all medium difficulty data questions. Today's challenge is to find students who improved. We have a table called scores with the student ID, subject, the score, and the exam date. We need to write a solution to find the students who have shown improvement. These are students that met both of these conditions. First, they have taken exams in the same subject on at least 2 different dates, and their latest score in that subject is higher than their first score. The result should be ordered. First, we want to partition our data set. Our partition is student and subject. Per each partition of student and subject, we want to find the first and the last exam date. So we write a select statement. And we use the raw number window function to find the first and the last exam date. As we just said, we partition by the student ID and the subject. If we order this partition by exam date in the ascending order, we will get the first raw number. Let's copy paste, and instead of ascending order, we will order in the descending order, and this will be our last raw number. Let's run this query to see the result. So this query gives us the student ID, the subject, the score. This is our partition because it has the same student ID and the same subject. First, we ordered the exam date in the ascending order. This is the earliest date, and therefore the score 70 has first raw number 1. For the last raw number, we ordered the date in the descending order, and the latest date has raw number 1. Let's also calculate how many rows each partition has. So we use the function count over the same partition, and we will call this column exam count. We will need this column to filter for those students that had at least 2 exams. This is not the final query that we need. This will be our subquery, and we will save it under a common table expression. So we create a common table expression called ranked scores, and the whole query should be pasted inside the CTE. Now let's do the comparison. We need to join this common table expression with itself. And then instead of just one column score, we will have 2 columns, first score and the latest score. So let's write another CTE called comparison. And we write another select statement, this time from ranked scores, and we join with itself. Since our partition is student ID and the subject, so we will join on these 2 columns. Let's run this comparison CTE just to see the result. And here we will select the student ID, subject, and the score column from each table. The score from the first table will be our first score, and the score from the second table will be our latest score. Let's also display the first and latest row numbers from each ranked scores tables. Let's call these columns correctly. This should be S1 first row number. This should be S2 first row number. Here S1 last row number and S2 last row number. Let's run the query to see the comparison table before filtering. This table gives us a lot of duplicates. This is because we are joining the same table twice. We are joining the table with itself. We are interested only in the row where the first row number from the first table is equal to 1 and the last row number from the second table is also equal to 1. Here you have our first score and latest score. In this case, 70 comes from the earliest date and 85 comes from the latest date, and we have these numbers here. Let's filter the comparison temporary table. Now we can delete these columns. I wrote them only to see the result and to understand the table, how the self-join works. Another filter we need is where the exam count is larger or equal to 2. We need at least 2 exams for each student and subject. All right, now we have the filter table. Let's look at the table again. The answer is still wrong, so we will have to filter more. One of the conditions is that their latest score should be higher than their first score. If we look at the latest score here, 60 is smaller than 65. This row is not expected to be in the output. So we need to filter that and order by student ID and subject. So let's do that, but we will do that in the select statement. So we select everything from comparison where latest score is larger than the first score. We order by student ID and subject. Now let's run the final query. We successfully solved this problem in SQL. Now let's move on to Pandas. In Pandas, we take the data frame scores and we sort values by student ID, subject, and the exam date. In this way, we ensure that we will have the first row in our partition, the earliest date, with the last row in this partition, the latest exam date. So we save this in a dataset called scores, and next we group and extract first and last scores. We group by student ID and subject. This is our partition. We call this dataset grouped. Now we filter for rows with at least 2 exams. We use the function count. And we need to check if there are at least 2 counts. We want to save the index of the row, which includes more than 2 counts or 2 counts, into our mask, which we will call eligible. Now we finally can get the first and last scores. We tick the dataset grouped, and from the column score we take the first score. We check if the condition is eligible, and we do the same for the latest scores. The location and eligible here functions as a filter or selector. This series and the eligible list share the exact same multi-index structure. Pandas performs a lookup based on the index. It looks at the first row and checks whether the tuple is in the eligible list. If yes, it keeps it. Next, we combine everything into a data frame. We create a Pandas data frame. The header first score will have the values from first scores, and the header latest score will have the values from latest scores. Very important, we need to reset index. When we perform the grouped operation, Pandas does not throw away the information we group by. Instead, it uses those grouping columns, student ID and subject, as the index of the new series. The reset index method performs two actions. It promotes the index to columns, so it takes the current index, student ID and subject, and promotes them into regular columns in the data frame. And it creates a new numeric index. It replaces the old index with a standard numerical range index, like 0, 1, 2, etc. So we do this in order to include student ID and subject as normal columns, because we will need them for the output. Before we output the data, we need to filter for improvement and order. This is the same what we did in SQL. We check if the latest score is larger than the first score, and we are ready to return the result. Our result should be sorted. We sort by student ID and subject. Let's run the code. And we successfully solved this problem in Python Pandas. Which syntax did you prefer for this specific problem? Raw number window function and self-join in SQL, or using first and last methods in Python Pandas, together with a location function as a filter and multi-index objects as a Boolean mask? Let me know in the comments.